Hello, in this lecture we'll find out the area of the orange shape using two different methods. In the drawing we have square ABCD. One side of square ABCD equals to 10 units. Inside the square we have two semicircles that intersect with each other. Semicircle DPC and the semicircle APD intersect with each other, and also a counter circle ABQD that intersects with this semicircle, and they actually create two lens. This is the big lens and also the blue lens. The blue lens is created by the intersection of the two semicircles with each other, and the big lens is created by the intersection of the quarter circle with this semicircle. Okay, so we have the big lens and the blue lens, and we want to find out the area of the orange shape. From the drawing it is very clear that the orange shape equals to the big lens minus the orange lens, minus the blue lens. Again, the big lens minus the blue lens equals to the orange shape. Okay, so we will actually find out the areas of the big lens and the orange lens. We subtract the area of the blue lens from the area of the big lens. In this way we find out the area of the orange shape. Okay, but first of all we'll explain two terms. The first term is the area of a sector. In the area, a sector is part of a circle, and the area of a sector equals to the area of the circle, that is pi r square, when r is the radius of the circle, times theta over 2 pi, when pi is equal, when 2 pi equals to 360 degrees. In terms of degrees, 2 pi equals to 360 degrees. Okay, so 2 pi radians equals to 360 degrees. So theta over 2 pi times pi r square equals to the area of this green sector. And another term is the area of the circular segment, the green circular segment. It is equal to the area of sector A or B, this sector, minus the area of triangle A or B. So if you subtract the area of triangle A or B from the area of sector A or B, we get exactly the area of circular segment AB. Okay, again, the area of sector A or B minus the area of triangle A or B gives us exactly the area of circular segment AB. Okay, so we start with the first method. The idea in the first method is that we will find out the length, general formula for the length of two semicircles that intersect with each other. Actually, a lens is defined as the common area that is created by the intersection of two circles or semicircles or quarter circles. So this is the lens that is created by the intersection of those two semicircles. So we find out the area of the lens. So those two semicircles could be any semicircles. They are not our specific semicircles. And after we find out the area of this lens, we use the general formula to find out the area of the big lens, and then we find out the area of the blue lens, and we subtract the area of the blue lens from the area of the big lens, and this is exactly equals to the area of this orange shape. Okay, so I repeat again. Actually, in both methods, we find out the area of the orange shape. The orange shape is actually defined as dpq. The area of this orange shape, dpq, is equal to the area of the big lens, the area of this big lens, minus the area of the blue lens. I repeat again that a lens is the common area that is created by the intersections of two circles or semicircles or quarter circles. Okay, so this is the idea to find out the area of this orange shape. Okay, so here we have two semicircles that intersect with each other. So here we will define the center of this semicircle as O, and we define the radius of this semicircle as A. Actually, those two semicircles intersect with each other at 90 degrees. They are actually perpendicular to each other. We define the center of this semicircle as M, and we define the radius of this semicircle as B. So here we define this point. This is the point of tendency of tangent MN with this semicircle, and N is the point of tendency. Of tangent NM with this semicircle. Okay, so here we have the radius ON, that is A, it is drawn to the point of tendency, that is to say, it is drawn to point N, that is the point of tendency, of tangent MN with this semicircle. So, and whenever you have a radius that is drawn to the point of tendency, then tangent MN will be perpendicular to the radius MO. So, tangent MN will be perpendicular to the radius NO. So if MN is perpendicular to NO, it means that this angle equals to 90 degrees. Here, point L is the point of tendency of tangent ML, that is also the radius of this semicircle, that is B. So it is the point of tendency of tangent ML with this semicircle. MOL is also the radius of this semicircle, that is equal to A. So here we have the radius OL that is drawn to the point of tendency, that is to say, it is drawn to point L, that is the point of tendency of tangent ML with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius OL. So if ML is perpendicular to OL, it means that this angle equals to 90 degrees. Okay. We'll join points L and N together by a straight line. And we actually divided this length into two parts. You have the upper circular segment NL and the lower circular segment NL. We'll find out the area of the two circular segments, and the sum of the areas of those two circular segments equals to the area of this length, that could be any length. Okay, so first of all, we'll find out the area of the green circular segments. So what is the area of the green circular segment? The area of the green circular segment NL equals to the area of sector NON is equal to the area of sector NOL minus the area of triangle NOL. Minus the area of triangle NOL. Repeat again. The area of this, the green circular segment NL, equals to the area of sector NOL minus the area of triangle NOL. So, in order to find out the area of sector NOL, we must know the angle between the legs of sector NOL. So here we will join points O and N together by a straight line. We define angle NOM. This angle is theta. And here triangle ONM, this triangle is congruent to triangle OLM. Those two triangles congruent to each other according to side rule. Why they congruent to each other? First of all, those two sides they are both equal to A, therefore they are equal to each other. Those two sides they are both equal to B, therefore they are equal to each other. And finally, OM is a common side that belongs to both triangles. Therefore, those two triangles congruent to each other according to side rule. Therefore, those two angles they are equal to each other. So if this angle equals to theta, then this angle must be also equal to theta, according to the rule that corresponding angles in congruent triangles are equal to each other. So I actually found out that angle NOL equals to 2 theta. Angle NOL equals to 2 theta. So the angle between the legs of sector NOL, it is equal to 2 theta. Yeah, it is equal to 2 theta. And according to the formula that I presented to you, you will get that the area of sector NOL equals to 2 theta over 2 pi times the area of the circle, that is pi r squared, and R equals to A, so it is pi A squared. Well, this expression is the area of sector NOL. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled, and we also have 2 in the numerator, 2 in the denominator, so 2 will get cancelled also. In conclusion, we actually found out that the area of sector NOL equals to theta A squared. Is equal to theta A squared. in the next step, we will find out the area of the lower circular segment, the area of this lower circular segment. So the area of the lower circular segment NN, I'll draw it in the orange color. From the drawing, it is very easy to see that the area of the orange lower circular segment of this lens it is equal to the area of sector NML So this is sector MNL minus the area of triangle NML. So this is the triangle NML, and in order to find out the area of sector MNL, we have to find out the angle between its legs. So we'll find out the angle between the legs of sector NML. We've already proved that those two triangles can relate to each other. So if you focus on triangle ONM, this right triangle, this angle equals to theta, this angle equals to 90 degrees or pi over 2 in terms of radians. So this angle must be equal to pi over 2 minus theta. Here, this angle equals to theta, this angle equals to pi over 2 or 90 degrees, so this angle must be also equal to pi over 2 minus theta. And therefore, the size of angle NML is the sum of those two angles, that is pi over 2 minus theta plus pi over 2 minus theta. So here pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that angle NML equals to pi minus 2 theta radians. Okay, so the angle between the legs of sector NML is equal to pi minus 2 theta radians. Okay. I'll repeat again. The angle between the legs NM and ML of sector NML equals to pi minus 2 theta. And the area of this sector equals to pi minus 2 theta over 2 pi times the area of the circle, that is pi r square, and r equals 2b, so it is pi b square. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. In the next step, we will open the brackets here, and we'll get that pi b square over 2 minus 2 theta b square over 2. So here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. In conclusion, the area of circular segment, the orange circular segment, equals to pi b square over 2 minus theta b square. And the area of this lens is equals to the sum of the area of the green circular segment plus the area of the orange circular segment. That is to say, it will be equal to the sum of the areas of the two sectors minus the sum of the areas of those two triangles. Okay? So here the area of the lens, that could be any lens, is equal to the area of the green circular segment plus the area of the orange circular segment. That is to say, it is equal to the area of sector NOL this is sector NOL plus the area of sector NML. This is sector NML minus the area of the two triangles NOL. This is triangle NOL plus triangle NML. We have already found out the areas of the two sectors. The only thing that is left to do is to find out the area of the two triangles and subtract each from the sum of the areas of the two sectors. So we'll actually, in order to find out the area of the two triangles, we'll combine them together. Side NO is A, side NM is B, side ML is also B, and side OL is A. This angle equals to 90 degrees. This angle also equals to 90 degrees. We'll join points O and M together by a straight line. So created here two right triangles, triangle NOM and the right triangle OLM. Okay, so we'll actually find out the area of each right triangle and we will add the area of the two right triangles. In this way we find out the area of the triangles. So the area of the green right triangle equals to A times B over 2 while the area of the here OL equals to A and ML equals to B. So the area of the orange right triangle equals to A times B over 2. So, and the sum of the areas of the two triangles is A times B over 2 plus A times B over 2. That is 2 times A times B over 2. 2 will get cancelled, and found out that the sum of the areas of the two triangles is A times B. So we have to subtract A times B from the area of the two sectors. We have already found out that the area of sector NOL equals to theta times A squared. The area of sector NML equals to pi B squared over 2 minus theta B squared. So this is the area of the two sectors, and from the area of those two sectors we have to subtract the area of the two triangles, that is AB, so it is minus AB. So in conclusion, we found out that the area of any length equals to this expression, so here so it is theta A squared plus pi B squared over 2 minus theta B squared minus AB. Here we'll take theta as a common factor from those two expressions, and inside the brackets, what is left from this expression after we took theta as a common factor, what is left is actually A squared. What is left from this expression after we took from it theta as a common factor, what is left is actually minus B squared. And we have also here pi B squared over 2 minus the area of the two triangles, that is AB, so it is minus AB. So in conclusion, the area of our lens, the area of this lens, that could be any lens, equals to theta times A squared minus B squared plus pi B squared over 2 minus AB. Okay. But we actually want to arrive to a formula that consists only A and B. So we must find out the value of theta. A is the radius of the first circle or semicircle or quarter circle, and B is the radius of the other circle or quarter circle or semicircle that intersects with the first circle or semicircles. Okay? So here we have triangle NOL, NMO. In triangle NMO, in the right triangle, triangle NMO, so this is the right triangle NMO that I copied from the original drawing. So here, tangent theta equals to NM over NO, NM over NO, so NM equals to B, and NO equals to A, so in conclusion, tangent theta equals to B over A, but we want to find out the value of theta itself, so in order to find out the value of theta, we'll operate the opposite function of theta on the result that is B over A, and we find out the value of theta. So theta, it is equals to the opposite function of tangents is tangents minus 1. We'll operate it on the result that is B over A, and we'll get the value of theta. So we found out that theta equals to tangents minus 1 of B over A. Now we can substitute theta by tangents minus 1 B over A. Okay. And we find out that the area of the lens, that could be any lens, equals to A squared minus B squared times theta, and theta equals to tangents minus 1 B over A. So now we can plus B squared plus pi B squared over 2 minus AB. So in this formula for the lens, for the area of a lens, the only missing variable are A and B, that are the radii of the two circles or semicircles or quarter circles that intersect with each other. And in this way they create the lens, of course. So we'll use this general formula for the lens in order to find out the area of the blue lens the area of this blue lens, and also the area of the big lens. Okay, so first of all we'll find out the area of the big lens. The area of the big lens was created by the intersection of the quarter circle with this semicircle, and the radius of the quarter circle equals to 10 units, so A equals to 10, and the radius of the semicircle, here we know that the diameter of each semicircle equals to 10 units, and the radius is equal to half of it. Because the radius, the diameter is twice as long as the radius, so if the diameter equals to 10 units, it means that the radius equals to 10 over 2, that is 5. So the radius of each semicircle equals to 5 units, so the radius B equals to 5. Now the only thing that is left to do in order to find out the area of this big lens is to put the values of A and B inside the general formula. In this way we find out the area of the big lens. Okay? So here, according to this formula, the area of the big lens will be equal to A square minus B square. A is 10, so A square is 10 square, minus B square. B is 5, so B square is 5 square, times tangents minus 1 of B over A. B is 5, A is 10, so 5 over 10 is 1/2, that is 0.5, plus pi B square over 2. B is 5, so B square is 5 square, that is 25, so it is 25 pi over 2 minus A times B. A is 10 and B is 5, so it is 10 minus 10 times 5. So here this expression, that is the area of the big lens, equals to 10 square is 100, minus 5 square is 25, 100 minus 25 is 75, so it is 75 times tangents minus 1 of 0.5 plus 25 over 2 is 12.5, so this expression in total equals to 12.5 pi minus 10 times 5 is minus 50. So in conclusion, we found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. In the next step, we find out the area of the blue lens. Here, the area of this blue lens. The blue lens is created by the intersection of the two semicircles with each other, and we know that the radii of each, the radius of each semicircle is equal to 5 units. So here the area of the blue lens the area of the blue lens we know that A equals to 5 units and B also equals to 5 units. So we put the values of A and B inside the general formula for the area of any lens, and we'll get that the area of the blue lens will be equal to A squared minus B squared. A is 5, so A squared is 5 squared, minus B squared, it is also 5 squared. It is actually equals to 0, but I will write down anyway the formula times tangents minus 1, B is 5 and A is 5, so B over A is 5 over 5, that is 1, plus pi B squared. B is 5, so B squared is 25, so it is 25 pi over 2 minus A times B. A is 5, B is 5, so 5 times 5 is 25. So we will find out that the area of the blue lens equals to this expression 5 squared minus 5 squared is 0. So in conclusion, we found out that the area of the blue lens will be equal to 25 over 2 is 12.5 pi minus 25. So the area of the blue lens equals to 25 pi, 12.5 pi minus 25 square units. So in the next step, we'll subtract the area of the blue lens from the area of the big lens, or the area of the big lens minus the area of the blue lens equals to the area of the orange shape dpq. Okay, this is the area of the blue lens. So the area of the orange shape dpq equals to the area of the big lens minus the area of the blue lens. Okay. We have already found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. So this is the area of the big lens, and from the area of the big lens we subtract the area of the blue lens, that is equals to 12.5 pi minus 25, and we'll get then the area of the orange shape dpq, the area of the orange shape equals to 75 times tangents minus 1 of 0.5. Here we have 12.5 pi plus 12.5 pi minus 50. We'll open the brackets here. So this, it is minus 12.5 pi, and we have minus 25 is plus 25. So in conclusion, I found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 12.5 pi is 0, so it will get cancelled. And we have here minus 50 plus 25. 25 minus 50 is minus 25. So in conclusion, the area of the orange shape that we are looking for equals to 75 times tangents minus 1 of 0.5 and 25 minus 50 is minus 25. Okay, so the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25, and the value of tangents minus 1 of 0.5, it is equal to 0.46. So we have to multiply 0.46 by 75. 75 times 0.46 equals to 34.77 minus 25 is the area of the orange shape. Okay, so in conclusion, I found out that the area of the orange shape, according to the first method, equals to 34.77 minus 25. That is equal to 9.77 square units. I'll repeat again, the area of this orange shape equals to 9.77 square units. That is, in general, the area of the blue lens, the area of the big lens, this is the area of the big lens, minus the area of the blue lens equals to the area of this orange shape, that is 9.77 square units. Okay, so we finished with the first method. So in the next step, I'll present to you how to find out the area of this orange shape according to the second method. Okay. In the second method, we will not use the general formula for the area of any lens, but we will directly calculate the area of the blue shape. We calculate directly the area of the big lens, so the area of the blue lens. In the first step we'll find out the area of the blue lens, then we'll find out the area of the big lens, and then we'll subtract the area of the blue lens from the area of the big lens. It is equal to the area of this blue orange shape dpq. Okay, so we will directly find out the area of this blue lens without any formula, but directly we find out the area of this blue lens. Okay, actually the blue lens was created by the intersection of the two semicircles with each other. They created the common area, and the blue lens is the common area of the two semicircles. So here we have this. Those are the two blue lens. Those are the two semicircles that intersect with each other, and we have already found out that the radius of each semicircle is equal to 5 units. So here in the second method we actually found out that this angle equals to 90 degrees and this angle equals to 90 degrees. I will not repeat on the same thing that we already found out in the first method. So this angle equals to 90 degrees, and here so here we know that the radius of this semicircle equals to 5 units, so A equals to 5. In the first method we have already found out that this angle equals to 90 degrees. It is a right angle. OL is the radius of this semicircle that is equal to 5 units. ML is the radius of the other semicircle that is also equal to 5 units. And M is also the radius of this semicircle that is equal to 5 units. So here we'll find out the area of circular segment NL, and then we'll multiply it by 2. In this way we'll get the area of this blue lens. Okay, we are looking for the area of this blue lens. So if we multiply the area of the green circular segment by 2, we'll get the area of the blue lens because of the fact that those two shapes are identical, because we have here the same radius. Okay, we just multiply the area of this green circular segment by 2. In this way we get the area of this lens, that is the area of the blue lens. Okay. So what is the area of the green circular segment? The area of the green circular segment NL the area will be equal to the area of sector NOL. This sector NOL minus the area of triangle NOL. I'll repeat again, the area of the green circular segment NL equals to the area of sector NOL minus the area of triangle NOL. This sector is a quarter circle. Okay, this is a quarter circle, therefore the area of this sector NOL will be equal to the area of the circle. Here this equals to 5, the radius equals to 5, 5, 5 and 5. This angle equals to 90 degrees. And this angle also equals to 90 degrees. So the area of the sector NOL equals to the area of this quarter circle. It is a quarter circle, that is to say the area of the quarter circle equals to the area of the circle, that is pi r square. R is 5, so it is pi times 5 square over 4. This is the area of the quarter circle minus the area of this right triangle, that it will be equal to 5 times 5 over 2. Okay, and then we will multiply the area of the circular segment by 2, and then we will get the area of the lens, that is actually the blue lens, because the blue lens was created by the intersection of the two semicircles with each other. It is the common area that created this blue lens. So we'll multiply the area of the circular segment by 2, and in this way we'll get the area of the blue lens. So the area of the blue lens will be equal to 2 times the area of the circular segment. So it is 2 times pi times 5 square over 4 minus 2 times 5 times 5 over 2. So here we have 2 in the numerator here and 2 in the denominator, so 2 will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 here also will get cancelled. And in conclusion, we found out that the area of the blue lens equals to pi here it is actually 4. It is 4 and we divide it by 2, so 2 over 2 is 1 and here 4 over 2 is 2, so here we left with 2 actually. So it is pi 5 square over 2, 5 square is 25, 25 over 2 is 12.5 pi, so this expression equals to in total to 12.5 pi minus 5 times 5 is 25. Okay, in conclusion, the area of the blue lens equals to 25 pi, 12.5 pi minus 25. So we finished with the blue lens. We found out the area of this blue lens. Now our mission is to find out the area of the big lens, and then we subtract the area of the blue lens from the area of the big lens, and this is the area of the orange shape that we are looking for. So in the next step we'll find out the area of the big lens. Okay. As I've already mentioned, the big lens is created by the intersection of the quarter circle with this semicircle. The intersection of the quarter circle with this semicircle created the big lens. Okay. So here the radius of the quarter circle equals to 10 units. And here, so define this point is point O. This point is point M. So here we have this radius that is drawn to the point of tendency. That is to say, it is drawn to point M. That is the point of tendency of tangent OM with this quarter circle. Whenever we have a radius that is drawn to the point of tendency, then tangent OM will be perpendicular to this radius. If OM is perpendicular to MN, OM is perpendicular to MN, it means that this angle equals to 90 degrees. Here we join the center of the quarter circle in the center of the semicircle. We join points O and N together by a straight line. Here we draw the radius of this quarter circle, and this point, and this point is tangent to the semicircle. Okay. We define the point of tendency as point Z. Here, this is the radius NZ of the semicircle that is here. We have here this tangent. So here we have the radius NZ that is drawn to the point of tendency. That is to say, it is drawn to point Z, that is the point of tendency of tangent OZ with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent OZ will be perpendicular to the radius NZ. So if OZ is perpendicular to ZN, it means that this angle equals to 90 degrees. OZ is tangent to the quarter circle at point Z. Point Z is the point of tendency, but OZ is also the radius of the semicircle because it starts from the center of the semicircle and ends at point Z, that is the point of the semicircle itself. That is to say, it is equal to 5 units because the radius of the semicircle equals to 5 units. For the same reason, point O is the center of the semicircle and point M is the point of the semicircle itself. That is to say, MO is the radius of the semicircle that is equal to 5 units. Okay. So here you have to find out the area of the big lens. We divide the big lens into 2 parts and we find out the area of each part, and then we will add the 2 areas together. It will be actually, of course, the area of the big lens. Okay, so we divide the big lens into 2 parts. That is to say, it will be divided by dividing the big lens into 2 parts. It will be actually divided to 2 circular segments. Okay, in the first step we'll find out the area of the upper circular segment. This green shape is the upper circular segment. In the second step we'll find out the area of this lower circular segment, and then we'll add the 2 areas together. That it will be, of course, the area of this big lens. Okay. Here, those 2 triangles, that is to say triangle NOM and triangle NOZ, they are congruent to each other. why those two triangles can go into each other. First of all, those two sides, they are both equal to 10 units, therefore they are equal to each other. In addition, those two sides, they are both equal to 5 units, they are the eye of the semicircle, so they are both equal to 5 units, therefore they are equal to each other. And finally, side NO is a common side that belongs to both triangles, so this side equals to itself. So actually we proved that those two triangles can go into each other according to side rule, and from the fact that they can go into each other, it means that if we define angle MNO as theta, because of the fact that those two triangles can go into each other, it means that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle equals to theta, then this angle must be also equal to theta, because those two angles are equal to each other. Okay? So here, what is the area of the green circular segment? But here, if you focus on this right triangle, this angle equals to theta, this angle equals to 90 degrees, that is pi over 2 radians. So this angle must be equal to pi over 2 minus theta. And those two angles are equal to each other because those two triangles can go into each other, and therefore this angle must be also equal to pi over 2 minus theta. In the next step, we'll calculate the area of the green circular segment. So what is the area of the green circular segment of the big lens? The area of the green circular segment of the big lens that is actually circular segment MZ. It will be equal to the area of sector MNZ. This is a sector MNZ. Sorry, for it here. Sector MNZ. This is sector MNZ minus the area of triangle MNZ. So this is triangle MNZ. Actually, we know that here NZ is the radius of the quarter circle that is equal to 10 units. MN is also the radius of the quarter circle that is equal to 10 units. So what is the area of sector M and Z? The area of sector M and Z, we know that the angle between his legs is theta plus theta is 2 theta. So it is 2 theta over 2 pi, that is 360 degrees. In terms of degrees, is 2 pi radians is 360 degrees. So it is 2 theta over 2 pi times pi r squared, that is the area of the circle itself. R equals to 10, so r squared is 10 squared, so it is pi times 10 squared. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator, 2 in the denominator, so 2 also will get cancelled. In total, this expression equals to theta 10 squared, that is 100 theta. 100 times theta. Minus the area of triangle M and Z, the area of any triangle equals to the multiplication of the two sides by each other times the angle between the two sides, the multiplication of the two sides by each other times sinus the angle between the two sides over 2. So it is actually equals to 10 times 10, 10 times 10 times sinus the angle between the two sides. The sinus the angle between the two sides is 2 theta over 2. So this is the area of the upper circular segment of the big lens. So here 10 times 10 is 100, 100 over 2 is 50. So this expression in total equals to 50 times sinus 2 theta. In conclusion, the area of the upper circular segment of the big lens MN equals to 100 theta, 100 times theta, minus 50 times sinus 2 theta. So in the next step we will find out the value of theta, and we also find out the value of sinus 2 theta. Those are the two missing things that we have in this area. So here we have, so in order to find out the value of theta and the value of sinus 2 theta, I will draw the right triangle NMO in this new page, and we find out the value of sinus 2 theta and the value of theta. This is the right triangle MNO. This is angle theta. In the right triangle, triangle MNO, it's very easy to see that tangent theta equals to MO over MN. Okay, so MO equals to 5, MN equals to 10. So in conclusion, I found out that 5 over 10 is 0.5. In conclusion, I found out that tangent theta equals to 0.5. Actually, I'm not interested in tangent theta itself, but we are interested in theta. So in order to find out the value of theta itself, we will operate the opposite function of theta on the result, that is 0.5, and we will get the value of theta itself. So here, tangent, the opposite function of tangents is tangents minus 1 of 0.5, and it is equal to theta. So we found out the value of theta is equal to tangents minus 1 on 0.5. In the next step, we find out the value of sinus 2 theta. What is the value of sinus 2 theta? So I will draw again the right triangle, triangle MNO. And we will find out the value of sinus 2 theta. This again equals to theta. We will implement the Pythagoras theorem on the right triangle, triangle MNO. According to the Pythagoras theorem on the right triangle, triangle MNO, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, NO squared equals to MO squared, that is 5 squared is 25, plus MN squared. MN squared is 10 squared, that is 100. So in conclusion, I found out that NO squared equals to 25 plus 100, that is actually 125. Here we take out of this equation and we find out that NO equals to the square root of 125. But 125 equals to 25 times 5, so we substitute 125 by 25 times 5. Here we take out of this equation, the square root of 25 is 5, so inside the root we left only with 5. So in conclusion, we found out that the hypotenuse NO equals to 5 times square root of 5. And we actually know that sinus 2 theta equals to 2 sinus theta cosine theta so sinus 2 theta equals to 2 times sinus theta. Here, what is the value of sinus theta? Sinus theta equals to MO over NO. Again, sinus theta equals to MO over NO. MO equals to 5 and NO equals to 5 times square root of 5. So in conclusion, sinus theta equals to 5 over 5 times square root of 5 times cosine theta. What is the value of cosine theta? From this diagram you can see that the value of cosine theta equals to Mn over NO. It is Mn over NO. So Mn equals to 10 and NO equals to 5 times square root of 5. So in conclusion, we found out the value of sinus 2 theta. So here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. So in conclusion, in the numerator we have 2 times 10 over square root of 5 times square root of 5 is 5 times 5. So here 10 over 5 is 2. So it is 2 times 2 over 5. 2 times 2 is 4 over 5. So in conclusion, we found out that sinus 2 theta equals to 4/5. Sinus 2 theta equals to 4/5. Okay. So I'll write down again the values that we have already found out. We actually found out that tangents minus 1 of 0.5 equals to theta, and we also found out that sinus 2 theta equals to 4/5. Okay. And we also found out that the area of the upper circular segment Mn of this upper circular segment Mn of the big lens is equal to 100 times theta minus 50 times sinus 2 theta. Okay. Now we'll substitute theta by tangents minus 1 of 0.5 and we'll substitute sinus 2 theta by 4/5. In this way we get the area of the upper circular segment of the big lens. Okay, so it will be equal to 100 times 100 times theta, and theta equals to tangents minus 1 of 0.5 minus 50 times sinus 2 theta, and we already found out that sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5. So it is actually the area of the upper circular segment MN of the big lens equals to 100 times tangents minus 1 of 0.5 minus, here this expression equals to 50 over 4 is 10, and 10 times 4 is 40. So in conclusion, the area of the upper circular segment MN of the big lens equals to 100 times tangents minus 1 of 0.5 minus 40 square units. So we finished with the upper side of the big lens. Now we'll find out the area of the lower circular segment. Okay? So I'll draw here this thing. So our mission is to find out the area of the lower circular segment of the big lens. Okay, to find out the area of this lower circular segment in the green color. So here, I'll not repeat on the same things that we already found out here. We have already found out that this angle equals to pi over 2 minus theta. This angle also equals to pi over 2 minus theta. So actually angle MOZ, this angle in total equals to the sum of those two angles, that is pi over 2 minus theta plus pi over 2 minus theta. It is pi minus 2 theta. So in conclusion, this angle equals to pi minus 2 theta, So what is the area of the lower circular segment MZ? The area of the lower circular segment MZ will be equal to the area of sector MOZ the length of each leg is 5 units, is the radius of the semicircle, and the angle between the legs of sector MOZ, it is pi minus 2 theta. So this is sector MOZ. So the area of circular segment, the lower circular segment of the big lens will be equal to the area of sector MOZ minus the area of triangle MOZ. Okay. This is triangle MOZ. Note that this angle equals to pi minus 2 theta. MO equals to 5 units, OZ equals to 5 units. So the area of sector MOZ equals to the angle between his legs is pi minus 2 theta over 2 pi radianin, this is 360 degrees in terms of degrees, times pi r square, and I equals to 5, so it is pi 5 square. So here we have pi in the numerator and pi in the denominator. So pi will get cancelled. So here we'll open the brackets and we'll get that 5 squared is 25. So it is here we have 25 pi over 2 minus 2 theta over 2 times 25. Okay, so here 25 over 2 is 12.5. So in conclusion, this expression equals to 12.5 pi minus we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So this expression in total equals to 25 theta. Actually, this expression equals to the area of sector MOZ, and also help to subtract from the area of sector MOZ the area of triangle MOZ. What is the area of triangle MOZ? The area of triangle MOZ will be equal to the multiplication of its sides by each other. That is 5 times 5 times sinus the angle between the two sides. That's sinus pi minus 2 theta divided by 2. So here we found out that the area of the lower circular segment, the area of the lower circular segment MZ equals to 12.5 pi minus 25 theta and here we have 5 times 5 is 25 over 2, and sinus pi minus 2 theta equals to sinus 2 theta. Okay, so in conclusion, the area of the lower circular segment MZ equals to 12.5 pi minus 25 theta minus 25 over 2 times sinus 2 theta, and we already found out that sinus 2 theta equals to 4/5. Okay, so the area will be equal to the circular segment MZ equals to 12.5 pi minus 25 theta, and we have 25 over 5 is 5, and 5 times 4 is 20, and 20 over 2 is 10. So it is minus 10. Okay. In conclusion, the area of the lower circular segment of the big lens equals to 12.5 pi minus 25 theta minus 10. Now we'll add the upper circular segment to the lower circular segment, and we will get the area of the big lens. Very simple. Okay. The area of the upper circular segment of the big lens equals to 100 times tangents minus 1 of 0.5 minus 40. So we'll add the two areas together, and in this way we'll get the area of the big lens. The sum of the area of the lower circular segment plus the area of the upper circular segment equals to the area of the big lens. So the area of the big lens equals to the area of the upper circular segment, that is 12.5 pi minus 25 theta minus 10 plus the area of the plus the area of this is actually the lower circular segment. It is 12.55 pi minus 25 theta minus 10 plus the area of the upper circular segment, that is equal to 100 times tangents minus 1 of 0.5 minus 40. Okay, so in conclusion, the area of the big lens equals to the area of the big lens equals to 100 times tangents minus 1 of 0.5 minus 25 theta, and theta equals to tangents minus 1 of 0.5, so it is minus 25 times tangents minus 1 of 0.5 here. The upper circular segment is 100 times tangents minus 1 of 0.5 minus 40. So here we have minus 40, and we have also minus 10 plus 12.5 pi. the area of the big lens equals to 100 times minus 1 of 0.5 minus 25 times tangents minus 1 of 0.5 is 75 times tangents minus 1 of 0.5 minus 40 minus 10 is minus 50 plus 12.5 pi. So this is the area of the big lens. We have already found out that the area of the blue lens, equals to 12.5 pi minus 25. So we subtract the area of the blue lens from the area of the big lens and we get the area of the orange shape. So actually the area of the orange shape will be equal to the area of the big lens, that is actually 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi this is the area of the big lens. Minus the area of the blue lens, that is equal to 12.5 pi minus 25. This is the area of the blue lens. Okay. Here we'll open the brackets and we will get that the area of the orange shape that we are looking for it is equal to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. So we'll open the brackets here, it is minus 12.5 pi. Minus and minus is plus, so it is plus 25. Okay, so here we have 12.5 pi minus 12.5 pi is 0 and 25 minus 50 is minus 25. So in conclusion, the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. And here tangents minus 1 of 0.5 equals to 0.46, and when we multiply 0.46 by 75, we'll get that is equals to 34.77 minus 25 it is equal to 9.77 square units. Okay, so we actually found out that according to the second method, the area of the orange shape equals to 9.77 square units. Okay, repeat again, the area of this orange shape dpq equals to 9.77 square units according to the second method. In the next step, I will summarize the lecture. We will start with the first method. So, in the drawing, we have square ABCD. One side of square ABCD equals to 10 units. Inside square ABCD, we have two semicircles that intersect with each other. Those two semicircles intersect with each other, and they create the blue lens. We also have the big quarter circle that intersects with this semicircle, and they create, by the intersection of the quarter circle with the semicircle, they create this big lens. And we have to find out the area of this orange shape. Actually, the area of the orange shape, this orange shape equals to the area of the big lens minus the area of the blue lens. Okay, the area of the big lens minus the area of the blue lens equals to the area of the orange shape. Okay, so according to the first method, we create general formula that we will use in this form. We create the general formula for the area of any lens, and by this general formula we calculate the area of the big lens. We calculate also the area of the blue lens, and we subtract the area of the blue lens from the area of the big lens. In this, that will give us the area of the orange shape. That is the idea of the first method. And first of all, I explained what is a sector. Here, the area of this green sector equals to theta, that is the angle between the legs of the sector, over 2 pi radians, that is 360 degrees in terms of degrees. 2 pi radians is 360 degrees, so it is theta over 2 pi times pi r squared. That is the area of this circle, because the radius of this circle is r, so the area of this circle is pi r squared times theta over 2 pi. That is the area of a sector. Okay, then I explain to you the term of circular segment. The green shape is circular segment AB. It is very simple to see from the drawing that the area of circular segment AB equals to the area of sector AOB. The area of sector AOB minus the area of triangle AOB will give us the area of circular segment AB. Again, the area of sector AOB minus the area of triangle AOB will give us the area of circular segment AB, the green shape. It is very easy to see it from the drawing. Okay? Then we actually created general formula that gives us the area of a lens. That could be any lens. So here we took two semicircles. We have here two semicircles that intersect with each other, and the common area that was created by the intersection of the two semicircles is this lens, and our mission is to find out the area of this lens. Okay? In this way we create general formula for the area of any lens, and we'll use the general formula in order to find out the area of the blue lens and the area of the big lens, and we subtract the area of the blue lens from the area of the big lens. In this way we get the area that we are looking for, that is the area of the orange shape DPQ. Okay? So here we define the radius of this semicircle as A and the radius of this semicircle as B. And those two semicircles intersect with each other with the angle of 90 degrees. They are perpendicular to each other. Repeat again, those two semicircles are perpendicular to each other. Okay, so here we have the radius ON. It is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent MN with this semicircle. Whenever you have a radius that is drawn to the point of tendency, then tangent MN will be perpendicular to the radius NO. So if MN is perpendicular to NO, it means that this angle equals 90 degrees. Likewise, we have here the radius OL. It is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent ML with this semicircle. Whenever you have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius LO. So if ML is perpendicular to LO, it means that this angle equals 90 degrees. Okay? Then we join points N and L together by a straight line, and we join points O and M together by a straight line. So we have here two diagonals, and by joining points N and M together by a straight line, we divided this length into two parts. Okay, we have the green circular segment and the orange circular segment, and the sum of the areas of the two circular segments will give us the area of this length that could be any length. Okay, so we will calculate the area of the green circular segment, and we will add the area of the green circular segment to the area of the orange circular segment. Okay. Repeat again. The area of the orange shape, the area of this orange shape equals to the area of the big lens minus the area of the small lens. So here, this is the big lens, and this is the blue lens. So if you subtract the area of the blue lens from the area of the big lens, we get exactly the area of the orange shape that you are looking for, the area of shape DPQ. Okay. In the first step, we calculated the area of the upper circular segment NL. The area of this upper circular segment equals to the area of sector NOL. This is sector NOL minus the area of triangle NL, minus the area of triangle NOL. Again, the area of sector NOL, this sector minus the area of triangle NOL will give us exactly the area of the circular segment NL, the green circular segment NL. So in order to find out the area of sector NOL, we have to find out the angle between his legs. Okay. So here we define this angle as theta, and then those two triangles can go into each other according to side rule. Those two sides are both equal to A, therefore they are equal to each other. Those two sides are both equal to B, therefore they are equal to each other. And OM is a common side that belongs to both triangles, so therefore those two triangles can go into each other according to side rule. It means that therefore if this angle equals to theta, this angle must be also equal to theta, because those two angles are equal to each other. So we actually found out that the angle between the legs of sector NOL is equal to theta plus theta is 2 theta. Side NO equals to A, side OL equals to also A. This is the radii of the semicircle. And the area of sector NOL equals to the angle between his legs divided by 2 pi, that is 360 degrees in terms of degrees, times the area of the circle, that is pi r square, and r equals to A, so it is pi a square. We have pi in the numerator and pi in the denominator, so pi will get cancelled, and we have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, we found out that the area of sector NOL equals to theta times A square. Okay? In the first method, we don't have to calculate at all the area of any triangle, because here we'll combine the two triangles together, and in this way we'll find out the total area of the two triangles, that it will be equal to A times B, and for that reason it is unnecessary to calculate the area of any triangle in the first method. So here then, so we don't have to calculate the area of this triangle. Therefore, we'll calculate the area of the second circular segment, the orange circular segment NL. The area of the orange circular segment NL will be equal to the area of sector NML, the area of this sector, minus the area of triangle NML. Repeat again, the area of circular segment LM, the lower circular segment, equals to the area of sector NML minus the area of triangle NML. We don't have to calculate the area of the triangle, so we calculate only the area of sector NML. In order to calculate the area of sector NML, we have to find out the area, the angle between his legs. The angle between the legs of sector NML is the sum of those two angles. So in triangle ONL, the right triangle, this angle equals to theta. This angle equals to 90 degrees, this is pi over 2, so this angle must be equal to pi over 2 minus theta. And here, this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to pi over 2 minus theta in order to complete the sum of the angles. In the right triangle to 180 degrees, this angle must be equal to pi over 2 minus theta. So the angle NML will be equal to the sum of those two angles. That is to say it is equal to pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the angle between the legs of sector NML, it is equal to pi minus 2 theta. Okay? So, and the area of sector NML will be equal to the angle between his legs, that is pi minus 2 theta over 2 pi times the area of the circle with radius b is pi b square. Okay? So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We open the brackets here, and here is actually pi b square over 2 minus 2 theta p square over 2. Okay? Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. In conclusion, we found out that the area of the lower circular segment, lower orange circular segment LM, equals to pi b square minus theta. It is not actually, we until this point we actually calculated the area of sector NOL and the area of sector NML. That's the only thing that we calculated. And we also, in order to find out the area of this lens, that could be any lens, we also have to subtract from the sum of the areas of the two sectors the area of those two triangles, because you can see that the sum of the areas of the two circular segments equals to the sum of the areas of the two sectors minus the sum of the areas of the two triangles. So we have to subtract the sum of the areas of those two triangles from the area of the two sectors. Okay? Repeat again, the area of this lens equals to the sum of the areas of the two sectors minus the sum of the areas of the two triangles. We have already found out that the sum of the areas of the two sectors is equal to this expression. In the next step we found out the sum of the areas of the two triangles. We actually combined the two triangles together. In this way we created quadrilateral NMOL. We joined points M and O together by a straight line. By joining points M and O together by a straight line, we created two right triangles. The green triangle is a right triangle, and the orange triangle is also a right triangle. And it is very easy to find out the area of the green right triangle. It is equal to A times B over 2. And the area of the orange triangle, orange right triangle, equals to also 2A times B over 2. And the sum of the two areas is A times B over 2 plus A times B over 2. That is actually equals to A times B. So in conclusion, we found out that the sum of the areas of the two triangles is A times B. So we'll subtract from the area of the sum of the areas of the two sectors, the sum of the areas of the two triangles, that is A times B. So in conclusion, we have to subtract from this expression A times B. We did it here. In this way, we found out the area of this lens. Again, the area of this lens equals to the sum of the areas of the two sectors, that is this expression, minus the sum of the areas of the two triangles, that is A times B. So this expression minus AB equals to the area of this lens. Okay, so here we took theta as a common factor. So what left from this expression after we took theta as a common factor, what left is actually A squared. What is left from this expression after we took theta as a common factor, what is left is actually minus B squared. So, and here we have also pi B squared over 2 minus AB. So in conclusion, we found out that the area of the lens, that could be any lens, equals to this expression theta times A squared minus B squared plus pi B squared over 2 minus AB. A is the radius of the first circle or semicircle, and B is the radius of the other circle or semicircle that intersects with the first circle. In this way they create the lens. The common area of the two shapes is actually the lens. So here we have theta, and our mission is to have the only variable that we will have in this equation is A and B, that is the radii of the two shapes. So we want to eliminate theta or to find out the value of theta. Okay, in order to find out the value of theta, I draw the right triangle NMO with a copy of the original drawing. So in this right triangle NMO, triangle theta equals to NM or NO. Okay, NM equals to B, NO equals to A. So in conclusion, we found out that triangle theta equals to B over A. Now, from this equation, we want to get the value of theta. Therefore, we will operate the opposite function of tangents on the result, and in this way we'll get the value of theta itself. So theta will be equal to the opposite function of tangents, that is tangents minus 1, that we operated on the result, that is B minus A, and this gives us the value of theta. Now we can substitute theta by this tangents minus 1 then over b of tangents minus 1 of b over a in the original on the equation of the area of the lens. So here we have a square minus b square times theta, and we already found out that theta equals to tangents minus 1 of b over a. Okay, plus pi b square over 2 minus ab. So here we created general formula to find out the area of any lens. Okay, we'll use this general formula in order to find out the area of the big lens. Then we find out the area of the blue lens, and we subtract the area of the blue lens from the area of the big lens. In this way we get the area of the orange shape. So the area of the big lens, here the big lens, it is actually was created, this big lens was created by the intersection of the semicircle with the quarter circle. Therefore, we have to find out the area of the quarter, the radius of the quarter circle, that is equal to 10 units. So A equals to 10, and the radius of the semicircle, we know that the diameter of the semicircle equals to 10 units. Therefore, the radius will be equal to half of it, that is 5 units. So B equals to 5 and A equals to 10. We put the values of A and B inside the general formula, and we found out that is equals to A square, A is 10, so A square is 10 square, minus B square, B is 5, so B square is 5 square, times tangents minus 1 of B over A. B is 5 and A is 10, so 5 over 10 is 0.5. Okay, plus pi b square, b is 5, so b square is 5 square, so it is plus 25 pi over 2 minus ab. A is 10 and b is 5, so it is minus 10 times 5. Here 10 square is 100, minus 5 square is 25. 100 minus 25 is 75. So this expression equals to 75 times tangents minus 1 of 0.5. 25 over 2 is 12.5 pi. 25 over 2 is 12.5, so this expression in total equals to 12.5 pi. Minus 10 times 5 is 50, so it is minus 50. Okay. So, in conclusion, we found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. And the area of the blue lens, actually the blue lens this blue lens was created by the intersection of the two semicircles with each other. The common area is the blue lens. We know that the area, the radius of each semicircle is 5. So A equals to 5 units and B equals to 5 units. So we'll put the value of A and B inside the formula, and we'll get that A square minus B square is 5 square minus 5 square, that is 0. And plus, it is plus pi b square over 2, b is 5, so b square is 5 square, that is 25, times pi over 2, minus a times b, a is 5 and b is 5, so 5 times 5 is 25, so it is minus 25. So in conclusion, we found this expression equals to 0, because 5 squared minus 5 squared is 0. So in conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25. So we subtracted, so the area of the blue lens minus the area of the big lens minus the area of the blue lens equals to the area of the orange shape. Again, the area of the big lens minus the area of the blue lens equals to the area of the orange shape, and the area of the big lens equals to 75 times minus 1 of 0.5 plus 12.5 pi minus 50 minus the area of the blue lens, that is 12.5 pi minus 25. We subtracted those two areas and we got the area of the blue lens is equal to 75 times minus 1 of 0.5 plus 12.5 pi. We open the brackets here and we found out that is equal to minus 12.5 pi, minus is minus is plus 25. So here we have 12.5 pi minus 12.5 pi is 0, and 25 minus 50 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. The value of tangents minus 1 of 0.5 equals to 0.46, and we have to multiply it by 75. So 75 times minus 1 of 0.5, in conclusion it is equals to 34 times 34.77, and we have to subtract minus 25. 34.77 minus 25 equals to 9.77 square units. Okay, so in conclusion we found out that the area of the green shape equals to 9.77 square units. We finished with the first method. Then I presented to you the second method. In the second method, we didn't created general formula for the area of any lens, but we directly calculated the area of the blue lens. Then we calculated the area of the big lens, and we subtracted the area of the blue lens from the area of the big lens. In this way, we get the area of the orange shape. Okay. Repeat again. We calculated directly the area of the blue lens, then we calculated directly the area of the big lens, and then we subtracted from the area of the we subtracted the area of the blue lens from the area of the big lens. In this way, we got the area of this orange shape, that is DPQ. The structure of DPQ, shape DPQ. Okay. So first of all, we calculated directly the area of the orange shape. So I draw the orange shape here. And here we know that the radius of, actually the orange shape was created by intersection of the two semicircles with each other. The common area of the two semicircles, it is the lens that we are looking for. It is the blue lens actually. So this is the common area between the common area that it is actually the blue lens, the common area of the two semicircles. And here we have, so we find out, we divided this lens into two parts. The two parts are identical, so we'll find out the area of this circular segment, the area of the upper circular segment of the blue shape, and we'll multiply it by 2, and we'll get in this way the area of the blue lens. Okay, I repeat again that the area of the upper circular segment, it is equal to the area of sector NOL minus the area of triangle NOL. Again, the area of the upper circular segment NL equals to the area of sector NOL minus the area of triangle NOL. Here, sector NOL is a quarter circle, therefore the area of a quarter circle is the area of the circle over 4, and r equals to 5, so the area of the circle is pi 5 square. And if we divide it by 4, we get the area of the quarter circle, so the area of the quarter circle equals to pi 5 square over 4, minus the area of this right triangle, that is the base times the height over 2, that is 5 times 5 over 2. So we found out that the area of a circular segment, the green circular segment, is pi 5 square over 4 minus 5 square over 2. So if we multiply the area of the circular segment by 2, we get the area of the blue shape. So we multiplied the area of the circular segment by 2, and found out that the area of the blue shape equals to 12.5 pi minus 25 square units. So we finished with the blue shape. Now we'll find out the area of the big lens, and then we subtract the area of the blue lens from the area of the big lens, and this way we get the area of the orange shape. So in the next step we'll find out the area of the big lens. The area of the big lens is created by the intersection of the semicircle with the quarter circle, and here those two triangles can go into each other according to side rule. So if this angle equals 2 theta, this angle also equals 2 theta. So angle MN, this MNZ equals to theta plus theta, that is 2 theta. So what is the area of the upper circular segment? The area of the upper circular segment will be equal to the area of sector MNZ minus the area of triangle MNZ. Repeat again, the area of circular segment, the upper circular segment equals to the area of sector MNZ minus the area of triangle MNZ. The angle between the legs of sector MNZ is 2 theta, so the area of the sector will be equal to 2 theta over 2 pi times pi r square, and r equals to 10, so it is pi 10 square. So in conclusion, the area of sector MNZ is 100 times theta minus the area of triangle MNZ. The area of triangle MNZ equals to 10 times 10 times sinus 2 theta over 2. In conclusion, it is equal to 50 times sinus 2 theta. So in conclusion, we found out that the area of the upper circular segment of the big lens equals to 100 times theta minus 50 times sinus 2 theta. Then I draw the right triangle, triangle MNZ, from this triangle we get the value of theta and the value of sinus 2 theta. In the right triangle MNO, tangent theta equals to 5 over 10, that is 0.5. So if tangent theta equals to 0.5, it means that tangent minus 1, 0.5 equals to theta. Then we found out that value of sinus theta. Here, here we have sinus 2 theta equals to 2 sinus theta cosine theta. We implemented the Pythagoras theorem on this right triangle. By implementing the Pythagoras theorem on the right triangle, we found out that the hypotenuse NO equals to 5 times square root of 5. So sinus 2 theta equals to sinus theta cosine theta. That is to say, it is equals to 2 times sinus theta. And sinus theta equals to 5 over the hypotenuse, that is 5 over 5, times cosine theta. Cosine theta equals to 10 over the hypotenuse, that is 5 times square root of 5. So in conclusion, we found out that sinus 2 theta equals to 4/5 and tangent minus 1 of 0.5 equals to theta. Okay? So the upper segment of the big lens, the upper circular segment of the big lens equals to 100 times theta minus 50 times sinus 2 theta. We substituted theta by tangent minus 1, 0.5, and we substituted sinus 2 theta by 4/5. And in conclusion, we found out that the area of the upper circular segment of the big lens equals to 100 times tangent minus 1 of 0.5 minus 40. Then we found out the area of the lower circular segment. We found out the area of this lower circular segment of the big lens. The area of the lower circular segment of the big lens in the green color equals to the area of sector MOZ minus the area of triangle MOZ. This equals to the area of sector MOZ minus the area of triangle MOZ. The area of sector MOZ, we know that the angle between his legs is pi minus 2 theta. Therefore, the area of sector MOZ equals to pi minus 2 theta over 2 pi minus pi r times pi r square. R equals to 5, so it is pi 5 square. So, in conclusion, the area of sector MOZ equals to 25 pi over 2 minus, that is actually 12.5 pi minus 25 theta. And the area of triangle MOZ equals to 5 times sinus pi minus 2 theta over 2. Sinus pi minus 2 theta equals to sinus 2 theta. So in conclusion, the area of the lower circular segment MZ equals to 12.5 pi minus 25 theta minus 25 over 2 times sinus 2 theta. Then we substituted sinus 2 theta by 4/5, and we substituted theta by tangent minus 1 of 0.5, and in conclusion we found out that the area of the lower circular segment MZ equals to 25 pi, 12.5 pi minus 25 theta minus this expression. So in conclusion, the area of the upper, we already found out that the area of the upper circular segment equals to 12.5 pi minus 25 theta minus 10. So, and the area of the upper circular segment equals to 100 times tangent minus 0.5 minus 40. And the area of the upper circular segment equals to 12.5 pi minus 25 theta, and theta equals to, actually, theta equals to tangents minus 1 of 0.5. So in conclusion, the area of the big lens equals to this expression. The area of the big lens equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. Okay, and the area of the blue lens equals to 12.5 pi minus 25. We subtracted the area of the blue lens from the area of the big lens and found out the area of the orange shape. The area of the big lens equals to this expression. The area of the blue lens equals to 12.5 pi minus 25. We subtracted the area of the blue lens from the area of the big lens, and we found out that the area of the orange shape equals to 9.77 square units. So in both methods we arrived to the same result, that the area of the blue shape equals to 9.77 square units. Okay, thank you very much.